Final velocity.
Okay, how about V of I?
Initial velocity.
How about A?
Acceleration.
How about this thing called, what is this thing called?
Change.
Delta. So what does delta X stand for?
That's your no.
Well, try again. What does delta X stand for?
Change of X.
And in this case, do we have the value for change of X?
No.
What would that be?
Unknown.
If you do, what would that be? Look at the questions and see if you can identify the known and the unknown. We start with the first sentence. Someone go ahead and read the first sentence.
Joni jogs at a velocity of 2.50 meters per second.
Right. So 2.50 meters per second, what would you consider that to be?
Velocity.
Is it initial or final?
Initial.
So on your table of known, you can start with the initial velocity, which is vi, and we know the value of vi is now equal to
2.5.
and this, be sure to put our vi and not just regular v, because we have two different v. We have vi.
Accelerates at a constant negative 0.10 meters per second squared. How fast will she be jogging when she has 10 meters?
Right. Now, if you look at the number, the value for acceleration, it's a negative number. What does that signify when you have a negative number for acceleration?
As a negative acceleration.
Right. Almost. Yeah, you're right. It's negative meaning it's on the same direction as you are moving or in the opposite direction. Okay. So if Johnny is jogging at 2.5 meters per second, which is a steady velocity, and now she accelerates at minus 10, does that mean she's going backward, or does that mean she's slowing down? Which one? Okay. Okay. Now, working on yourself, which would make sense to you? Here I am, Johnny, jogging at 2.5 meters per second, and now I have a negative acceleration of minus 0.10 meters per second squared. Does that mean I'm now going backward, or does that mean I'm slowing down?
In the picture you can see how the initial velocity is going this way, but the acceleration is going opposite, but it's still forward.
Right. Is it possible, ever possible, that I can be going backward?
You can
Or else, look at the magnitude. If you look at the magnitude, the velocity is 2.5. That's right, 2.5 meters per second, whereas acceleration is minus 0.1. So, no, you're good. No, once again, in a graduate seminar, it is not the professor who will talk the most. The professor will try to get all the graduate students to do most of the talking because you are doing the thinking. And all the professor doing is just trying to guide you along the way. But he will not think for you. That's not what he's supposed to do. He's supposed to stimulate you so you can think for yourself. So think of a case in which I can have negative acceleration, and that means I'm going backward. How could that be?
being pushed back.
How about if I say he's going at 2.5 meters per second, and then he accelerates at a constant of minus 10 meters per second squared. He may. What happens is that if you go as a constant velocity, and then you have a minus 10 meters per second squared, then what happens is that you will slowly come to a stop. And if you continue with that negative acceleration, then you're going backward.
Yeah, it's constant, so you have to go back.
Yeah. You won't go backward immediately. There's a short span of time in which you have to slow down, come to a stop, and then eventually going backward if you maintain the same negative acceleration. All right. So now you have initial velocity, which is 2.5. You have acceleration. What is the value of acceleration?
0.5.
Okay. And what you're looking for, do you have delta x? Look again, do you have delta x?
Yes.
No, that's not true. Look at the second sentence. Do you have delta x? Why do you have 10? That's the correct answer, by the way. Yep, and she has moved 10 meters. So we know that the change in displacement is 10 meters. So now you have initial velocity, you have acceleration, and you have displacement. And now what you do is element and solve for the final equation.
So everything's there. You just wanna know
That's the one number. What is the question?
how fast it's going to be.
Which is, it's a final or initial.
And the final.
Yeah, so that's only one number, final velocity. And that's how we do it in a seminar, in which, in this case, I didn't do a correct job. I talked too much. But if we will continue doing this, then you can see me doing less and less talking and sort of nudge you to go to the right direction, but I didn't do most of the talking. Got it?
Yeah.
You do? Okay? So, what is delta x equals? Yep. So write them down. Delta x equals 10 for the no value. And then I'll show you what I've done here on the screen, which is basically the same thing. Alter your calculation. Check this out.
Oh, yeah, we do.
I square this. Alright, meter per second is square. Over here I got meter, second square, so time. Everything is square. And by the time I square them, so that when I take the square root, I would end up with the proper unit for velocity. And that is how you verify that you have the correct answers. Because you have used applied unit all in your equations. So that your final result should have the proper unit. And that's how you know that you have done it correctly. For your own, do it on the back of your head. Just turn it around and do it on the back of the paper.
Thank you. Yeah, I like it.
All right. You know what you're doing. I'll take it. Thank you. Yes. Once again, we do the same thing. Go ahead and discuss it on yourself on what are the knowns and the unknown in this case. And I will not talk anymore. I will talk actually.
Alright, so knowns we have velocity of 2.0 meters per second.
Is that initial or final?
This would be the initial.
Okay. How about people all second? What is that?
We have time and acceleration.
Okay. So what are we looking for?
Delta x.
How many go about getting delta x then?
Huh?
How
This is the displacement.
Three, four?
So then after like 3 seconds you need to go like slow down.
This way?
Because it goes to a negative.
Well, actually, yes. And notice this, slow to a stop. When the cat slows to a stop, what will be the final velocity? When something comes to a stop. Yep. So you do have another known here. You have the final velocity is 0 because it's that slow to a stop. And this is how physicists catch to this little detail. You don't see the number 0 in the person, but you see the sentence stop. And from that you can deduct that the final velocity is equal to 0. So you have the initial velocity and the final velocity.
No. Wait, what are you plugging time now?
Okay. Yep. So now it's up to you to figure it out. How do I determine displacement? I give you a couple of minutes to think it over and I'll show you how. watch the movie, so let me wrap it up.
And order the pizza.
So you start with the, okay, you start with the no, you have this no, right? Okay, and you look at the no. Okay? So you have a picture of the cat. Okay? And so we start with this. The change for displacement is equal to velocity times change in time. We have that. And then you apply the equation that I showed you earlier to solve for the second displacement. Now, go ahead and take a minute, look at this, see if it makes sense to you. I have two displacements. Alright? I have the initial displacement right here. And then I have a second displacement. Okay? That's why I have two parts, part 1 and part 2. And I do a demonstration. Pretend I'm a cat, I'm running at a constant velocity.
You gotta
so
do
that
it.
part 1. Yeah. And part 2 is when I slow down. So there's two parts. Part 1, there's no acceleration, constant velocity. Part 2 is when I slow down. So you have two parts. So you have two displacements. So the first one is easy. Displacement is equal to velocity times time. So that gives you the initial 610 meter just for part 1. Part 2 is when I slow down. That's when you apply the equation to get the displacement for the second part. And then you combine it together. Get it? Get it up? Now, to make sure that you do get it, I'll turn it on and ask you to do it again. She got it? Right?
Yeah.
Alright, let me see it.
It's 2.5.
It's too much. The answer's too
It's because really for the thing is I don't know what
Mm-hmm. That's the thing, though. You can just change from 1 to 1. I mean,
much. 2.5 meters per second.
you start with the nose and say no.
Oh,